Hello, my name is David Sims. I'm a graduate student at California State University Long Beach, and my major is Geographic Information Science. The purpose of this tutorial is to demonstrate how to use Python tools which I developed. These tools will help you use slope, derived from a digital elevation model, to help you improve classification of Landsat imagery. In this demonstration, the classified imagery I used was created with ERDOS Imagine and unsupervised classification. However, these same tools can be used with a variety of classification methods. Go ahead and download the My Workspace folder, and you'll find a link for that below. Once you do so, make sure you've saved it on your machine because it will not work with an external device. Open the folder and go to this very top folder here, 01 Classification Tools. In here you will find the two Python tools and the workflow that these tools are based on. In this document you'll find the workflow overview. This basically summarizes how the tool works. If you want to read about this in more detail, feel free to do so. There's 28 pages to read. But what you really need to get from this document is your 4 slope classes, which are going to be unique for your study area. Go to page 15 and you'll find instructions on how to do that. So you're going to want to have 4 slope classes that are unique for your study area, and the way you can determine what those class ranges should be is by going to Google Earth, zoom to your study area, and zoom to a feature that you want to determine the slope for. Click on this measure tool up here, make sure your units are set to miles, and measure out a predetermined distance that is suitable for whatever feature it is that you're trying to determine slope for. In this example, we're looking at a playa in the Mojave Desert, and I've measured out 1 mile. So as you measure out this distance, carefully watch the change in elevation and then record this change. Do this for all 4 slope classes. Once you've got your rise over run for all 4 of the classes, you can click on this online calculator. Plug your distance and vertical change in here, and it's going to spit out your percent slope, and then you can use these for your class ranges. Now I would like to explain the premise of this tool and what its purpose really is. So if you've ever used unsupervised classification, or really any classification, you know that you always end up with misclassified pixels. This is especially true with unsupervised classification. And so I'm going to explain the premise of this tool using the playa class. In this study area, the wind constantly blows from west to east. It picks up sediment from the playa and then deposits it on the adjacent mountains on their windward slopes. This forms climbing dunes. These dunes can extend high up the mountain, more than 1,000 feet above the surface of the playa. During the classification process, the software identifies these pixels as playa and groups them together. This is because they're essentially made out of the exact same material. But we know that playa do not occur at the very tops of these jagged mountains. So basically, we want to tell the software, show me all the pixels that are marked as playa, and isolate those where they're also located on top of mountains. And by doing so, we can zoom in, determine what class they actually belong to, reassign them a new value, and change their class. And so that's really the premise of how this tool works. And the conditions and environment in your study area may be different, but you may have similar things going on in your area. Maybe you have vegetation in a flat plain, that's high biomass that you've classified within DVI, but then the vegetation community totally changes as it gets into the mountains, and you could isolate that high biomass vegetation and change its class to something more suitable compared to what you're finding along maybe riparian habitat out in the flatland or desert below that's also being classified as high biomass. All right, so that's basically the premise of this tool, and we're ready to proceed to the next step. Okay, so next open up ArcMap and open ArcCatalog, connect to my workspace folder, and then copy and paste your DEMs into the DEM folder. And then you'll see I have two here. You may only have one for your study area. That's fine. In my case, I need to mosaic these two DEMs together. And then copy and paste your classified image file into this unsupervised folder. Go ahead and load this file into ArcMap and bring up the attribute table. And so if you've already dissolved all these fields using ERDOS recode tool, that'd be fine. If not, then what you want to do here is to carefully go through and make sure everything is spelled exactly the same. For example, if you have basalt spelled with a capital B and then you had it spelled with a lowercase b in the final output, you would end up with two separate classes here. And at this point, go ahead and use these large descriptive names here. These are going to help you in the next step to assign these to appropriate classes after you apply slope. And you're going to have another chance to rename these to the final class names. Alright, so go ahead and close ArcMap. And then run the tool. Oh, first you want to copy your workspace path. Okay, now run the tool. Right click, edit with idle, don't use Python Win. Okay, so first thing we need to do is enter all the parameters that the tool will need to run. Begin by pasting your workspace path here. Does your area of interest require you to mosaic DEMs together? In this case, yes. The following files were found in the unsupervised folder. Enter the name of the unsupervised classification file as it appears above. Include the extension unless it is Ezra Good format. In this case, we have a .img. The projected coordinate system for all Landsat data is WGS 1984, UTM zone, whatever. All outputs will match the UTM projection in the unsupervised classification file. The geographic transformation used is only suitable for the lower 48 states. Now I want to point out here that in this example we are using Landsat. However, this tool should work with any sensor just as long as the file format is something compatible with ArcMap such as .img, and also that it is in the WGS 1984 UTM projection. If it's not already in this projection, you could always just reproject it and then run the tool. And also, you could use this tool anywhere in the world, given that you go in and modify the geographic transformation in the script, and that's really easy to do, and I will show you how to do that in the next video. The fields below were found in the unsupervised classification file. Type the name of the field that represents land cover classification as it appears above. In this case, it is class name. The following files were found in the DEM folder. Now, your file probably has some really big, long name if you just downloaded it from the national map, and that's no problem. I set it up so you'll be able to just copy and paste, or you could just type it. And when you've added all the DEMs that are going to be necessary for your study area, simply type done. Next, we're going to enter all the parameters for our slope classes. So slope class 1 is 0 to 0.04, 0.04 to 5, 5 to 30. And by default, whatever value is entered here, class number 4 is going to be everything greater than that. In this case, everything greater than 30% slope. The cell size of the unsupervised classification file is 30 meters. This would be different if you were using a different sensor. The cell size for the DEM is in angular degrees because they're not projected when you download them from the national map. So a 1/3 arcsecond DEM, which is probably the most common size, has a cell size of 10 meters approximately. If you have a different size, which they do have available, just Google that information, and then that is the cell size that you probably want to use here. But one of the cool things about this tool is it lets you quickly experiment with different cell sizes. Alright, so the output cell size for all files will be 10 meters. And now the tool's running, so I notice it goes a little slower with the video capture software. If you ever wonder if the tool's still running, you can just bring up Task Manager and look at the Performance tab. And if you see that about 10 to 25% of the CPU is being used, then the tool's running. If you're seeing like 0 to 6%, then it's frozen. And the only time I've had it freeze is when the data was stored on an external device. Alright, the mosaic process is complete and the file below has been created. So the tool is going to confirm with you after each step is completed, and it's going to tell you where the file that was generated is stored. And so these first 2 steps take the longest because the DEM is still full sized. It has not been clipped to the extent of your classified image file yet. Right after these first 2 steps, it starts running a lot faster. Alright, DEM mosaic has been projected. The cell size was changed during this step to 10 meters. Bilinear interpolation was used to resample pixels. Here bilinear was used because this is appropriate for continuous data such as elevation. The projected mosaic file has been clipped to the unsupervised classification file extent. DEM clip will be used as a snap raster for all outputs after this point. And so what a snap raster does is this ensures that all these outputs are all going to have perfect cell alignment. The clip DEM was used to calculate percent slope, and the file below has been created. And now slope class 1, 2, 3, and 4 files have been created. The lookup tool is finished running. The cell size was changed from 30 to 10 meters. This 30 and 10 may be different depending on your sensor and whatever you entered for your cell size. Nearest was used as a resampling method. And here nearest was used because nearest is appropriate for discrete data such as a classified image. Okay, so now the tool is applying slope to all of the classes that were in your classified image file. And since we have 4 slope classes, you're going to generate 4 files for each one of those classes in your classified image. Therefore, if you had 10 classes times 4 slope classes, you're going to generate 40 files. Therefore, I suggest that you keep your number of classes to be like 10 or less. Just to give you an idea, I ended up with 36 files, and it took me About an hour and a half, although I've been through this several times, to uh, completing the next step. So that gives you an idea how much time it might take. Maybe if this is your first time, doing this in your study area, it might be like 2 hours. So you can do it with more classes, but it's going to take you longer and be more tedious. Okay, so the tool's finished running, and it's going to confirm with you how many files were generated. In this case, it was 36. And where they're stored, they are all in the raster calc outputs 1 folder. This is all of the classes and their associated value that are in the classified image file now. And here's your 4 slope classes that you use, and you're going to need all of this information in the next step. So just copy and paste this into a Word document. Once you've done that, go ahead and open ArcMap, and we're ready to proceed to the next step. Okay, so once you open ArcMap, go to the Add Data tab, and make sure you use this and not Arc Catalog, because you'll be able to grab all the files that are in the raster calc output 1 folder by holding Shift, and then you can just add all those at once. It may ask you about drawing pyramids, building pyramids. Just click yes, and then there'll be like a checkbox to do it for all the layers. So this whole process is going to kind of be like basically the same thing that you would do in unsupervised classification, where you change the color of the pixels to something bright like fluorescent green. You evaluate what class they belong in, and then you change their color to what you want it to be for that class, and then you go in, add the class name, assign new value. So that's basically what we're going to do again. So the first thing you want to do is go in here and right click on every single file and change the 0 to no color. Okay, once you've changed all the zeros to no color, go through and turn off every layer. After you've completed turning off every layer, add an imagery base map. Now that all the files have been turned off and you've added a base map, you can begin going through here and changing the color for all of the 1 values to something that represents the final class you want this file to belong to. And take note that a stringent naming convention is followed, so this would be unsupervised class 5, slope class 2, unsupervised class 5, slope class 3, unsupervised class 5, slope class 4, and then it will repeat, unsupervised 6, slope 1, and so on. And so you can look back to the information you pasted into the Word document after running the tool and determine what was contained in this class and what the slope is, and that can help you make better decisions as you determine what class is going to belong to. So similar to unsupervised classification, we're going to turn on the file. Now here these stand out pretty well, but if there's fewer pixels, some of these only have a couple 100 pixels that you won't even see, and as you start to fill in this image, you're going to start, it's going to start getting very crowded, and you're not going to notice what turns on and off, so you can just make this a bright color. I like to use green myself. Alright, so I know that this is volcanic, and based on the slope class 2, this is going to be volcanic plain. My color for that is this lilac here. Okay, next one. This is volcanic slope and amethyst. And I already know this is volcanic mountains. I've been through this a lot of times, so this is kind of easy for me, maybe more difficult for you. And so you're just going to continue this process all the way down through all your files. And um, I'm starting in the middle here just because it's easy for you to see it, because there's a lot of pixels. Up here, if I was to start here, there's only a couple hundred pixels contained in this file. You can't even see them. And so you may have problems visualizing these, so you can turn off the base map and view it against a white background. You could add the DEM that's been clipped and view it against a black background, which I find even more useful. And I also find it useful to move all of the files into a new group layer, so you can turn all of them on and off with one click. And so then you can turn all of them off and drag one out that you're having problem finding the pixels for, and then view this by itself just on top of the DEM or the base map or whatever. So good luck, and after you complete that, we're ready to move to the next step. Now that all of the colors have been changed for every file to something that represents their final class, we need to go in and change all of these ones, because see, this would be playa for white and this would be volcanic plain, but their value is 1 for each of these. So you have this with all these binary rasters here. What we need to do is give this a unique value that's going to represent the final class. So begin editing, and then open the attribute table, and you'll see that the tool added this class number field, and this field is going to represent the value of that final class you want it to be in. In this case, playa is class 1, and this class 2, volcanic plain. Now you might want to write down the information, like the number that you want to correspond to each class in the final output. That can maybe help you stay organized. I know from my color scheme which class it's going to belong to. All these purple ones are volcanic, the red ones are granitic, the gray is the basin, and so on. So as long as you have your color scheme memorized, it should be no problem. And so go through and continue doing that for all of these. So the only thing here is you cannot use a 0. You can use any numbers you want for these classes, but you can't use a 0. So if you have 9 classes, you're going to use 1 through 9. Do not use like 0 through 8. Okay, once you do that, you'll be ready to run the second part of the tool, which is going to merge all these files back into one single file. I've now completed going through every single file and changing the class number right here, except for this one. And I left this as 0 intentionally because I realized that this is really easy for you to miss one of these files and leave it as 0, and I set the tool up to account for that, and this way I can demonstrate how that works. Just like before, copy the path to the My Workspace folder, and then right click on the second part of the Python tool, edit with idle, go ahead and run the tool, and then paste the workspace path. And that's it. The tool is running and it will take a few minutes to complete. The tool has finished running, and you'll see that it produced an error message here. You did not enter a class number for the file in the raster calc outputs 1 folder listed below. And so all you need to do is go back into ArcMap and edit the class number for any files that are listed here. And then run this tool again, and if you run this tool and you do not get an error message, then you're almost done. So the final file is the final mosaic, and that is in the process products folder. Open ArcMap and bring that up. Once you add the final mosaic file to ArcMap, you'll probably see just one solid color here. What you need to do is open the attribute table, and you're going to find the class name field is completely blank. So start editing and then fill out all the class name information. Then save your edits. Once you've done that, go to the symbology, and you're going to want to use unique values. And for the value field, class name, then click add all values. All your classes should pop up here. Simply change their color. And that's it. Congratulations. You've successfully used slope to improve unsupervised classification of Landsat imagery. Please check out my other videos where I will explain each line of the code, and also another video that explains future research where you could use aspect to improve classification to get rid of some shadows here. For example, here we have shadows that are misclassified as mountains, and also you could use this similar technique using elevation in areas with strong altitudinal zonation to improve classification as well. Hope you've enjoyed it. I know I have. Thank you for viewing.